So we are working through our motion free response. Again, we're just going to do these four that we've, you guys should have already done these four, so we're going to do these ones. And then I'm not going to assign any more before the quiz on Wednesday, because Tuesday we have the review of the multiple choice for the applications of integration to geometry. But there's still at least probably, I don't know, I guess if this is page 7 and we're doing through page 10, there's pages 11 through 28 of more extra problems for you to practice if you want. I can answer questions on those as you ask them. You can send me a reminder or whatever. Oh, other important thing before we do this problem, I should have thought of all this earlier, but on the College Board website, in the My AP Classroom, I've started to unlock all of the, like, they call them quiz things. So it's just going to be practice problems for you guys to work through that are from each different section. There's some multiple choice, there's some free response in there. So I will begin to work through I'm not going to work through those with you, but you can begin to work through them if you want. My suggestion, though, is that you kind of hold off on those a little bit and just try and work through those, or starting maybe around spring break and up until the time when you're actually taking the AP test. So you do a little bit each day so you don't forget everything. That would be my suggestion. So, all right, here we go. Part A. We got to do this now. So part A, we got a particle moving along a straight line. We're given its velocity function. We're told that the position is s of t, and we know that the position at t equals 0 is 10. So the first thing we want is the values of t between 2 and 4, where the speed of the particle is 2. So important that we have to remember, what does speed mean in terms of the velocity? Remember that speed is the absolute value of the velocity. So we want to know, when does the absolute value of the velocity equal 2? So you'll just graph both of these and use your calculate intersect function on your graphing calculator to get that those occur. There's, I think, 2 different places. One is 3.128, and the other is 3.473. So just graph absolute value of this function, graph y equals 2, and get those 2 values. Everybody good with that? Hopefully. Yes. Great. 1 point for setting up this equation, and you need to write the equation. You need to write absolute value of v of t equals 2, and then you get that point, and then 1 point for the other values over there. All right, part B, write an expression involving an integral that gives the position of s of t. So remember that position is the integral of the velocity. So we want the position at any time t. So we're going to integrate from 0, which is where we know our initial condition at, to t of our function. And note that I know this is v of t, but I wrote it as v of x dx. You could choose any variable in here, but just make sure it differs from the variable of t in your upper limit. Otherwise, things become a mess. If you have v of t dt integrated from 0 to t, that's just like a sort of that's an issue, because then you're evaluating variable t at variable t. You want to evaluate x's at t, not t's at t. So just make sure you change the variable on the inside of here. And then we also have to, since we're talking about position, we have to include the initial position, which was at 0, it was 10. So 10 plus the integral from 0 to t of v of x dx. If they told us that s of 1 was 10, not s of 0, then this integral would go from 1 to t. If they told us that s of 2 was 10, we'd do 2 to t. If they said that s of 0 was 17, we'd have a 17 out here and go from 0 to t. Everybody good with the first part of B there?
Yep.
All right. Second part says we need to evaluate that for t equals 5. So we're looking for the position at t equals 5. So we'll just plug in 5. So s of 5 is 10 plus the integral from 0 to 5 of our function. And that should have come out to be negative 9.207. And this was worth 2 points, 1 point for the function over here for S of t, 1 point for our final answer. Any questions there on A or B? All right, part C. We're looking for all time t in this interval 0 to 5 where the particle changes direction. So in order for the particle to change directions, the velocity must become 0 and then change from positive to negative or negative to positive. So first thing we'll do is we'll just set v of t equal to 0. And because you are so lucky to have a graphing calculator on this problem, you'll get 2 different values for that, 0.536 and 3.318. And you can either make yourself a sign chart and say, here is 0, here is 5, here is 0.536, here's 3.318. And you can look at the graph of your velocity and determine when velocity is positive and when velocity is negative by just plugging in the values into it, or just look at the graph and see when it's above the x-axis or below the x-axis. But you'll find that v of t starts out negative, so moving to the left, becomes positive, so moving to the right, and then comes back to being negative, going back towards the left. And so you'd see that there's a sign change at 0.536 and a sign change at 3.318. And you could then say changes directions at those 2 values. Or you could just write out a sentence based on looking at the graph, and that would be fine too. Everybody good with part C there? And that was worth 3 points, 1 for this and 2 for the answers with the justification. All right, for part D, we want to know if the speed of the particle is increasing or decreasing at t equals 4. So remember that to figure out if the speed of something is increasing or decreasing, we have to look at the velocity and the acceleration. And if those have the same sign, then the speed is increasing. And if they have opposite signs, then it's decreasing. So we'll just find v of 4 using our calculator. And v of 4 came out to be negative 11.47 something. 476. And v prime, or a, of 4 came out to be negative 22 point something 295 something. And since we note that this is less than 0 and this is less than 0, we would say that speed is increasing because a of 4 and v of 4 have the same sign. And you want to make sure that you explain that that's, just writing less than 0 is probably not. It's probably good enough actually for most people that might be grading your AP test, but some people might want to see the written out explanation. And if you are unlucky enough to get the person who is super particular about what you've written, then make sure you write it because you don't know. So 2 points for the conclusion with the reason. Good or no?
Good.
Wonderful. Anybody have any questions on that one before we move on to this non-calculator one? Great. All right. So Non-calculator, we're given a velocity, given an initial position. We want to know when is the particle moving to the left between 0 and 12. So it's moving to the left whenever v of t is negative. In order to figure out when v of t is moving to the left and to the right, we need to figure out when it stops, when it's 0, to see when it can change directions between left and right. So we'll set v of t equal to 0. So we're going to look for when does cosine of pi over 6t equal 0. That means that cosine of some angle equals 0, which tells us that that angle, pi over 6t, needs to equal pi over 2, or 3 pi over 2, or 5 pi over 2, or 7 pi over 2, pi over 2 plus any pi n, where n is any integer. And so then you just go ahead and solve this. We're going to divide everything by pi and multiply everything by 6, which tells us, if we do that, we're going to get 3 here, right? If I divide pi over 2 by pi and multiply by 6, and this will be plus 6n. So then you just plug in values of n into your little equation here until you get outside of that interval. So if n is 0, t equals 3. If n is 1, t equals 9. If n is 2, t equals 15, which doesn't fall in your interval. So the only places where it could change directions between 0 and 12 are at 3 and 9. And then you'll just plug in some values here. Like if I plug in 0, the cosine of 0 is positive, so it's moving to the right. If I plug in 12, the cosine of 2 pi is positive, so it's moving to the right. And if I plug in something in between like 6, the cosine of pi is negative, so it's moving to the left from t is greater than 3, less than 9. Good or no? 1 point for setting v of t equal to 0, 1 point for the interval. Any questions there?
Did we have to do a sign chart, or could we just like reason it out by like putting cosine as negative for the interval?
Yeah, that would be fine. I mean, you'd have to write something to say, okay, cosine is negative when t is 0 to 3. I mean, sorry, when t is 3 to 9. That'd be fine. Like talking about which quadrant or something that is, or something like that. You know what I mean? Like, so like you could say this is quadrant 1, this is quadrant 4 where cosine's positive, this is quadrants 2 and 3 where cosine's negative. So it must be moving to the left. Does that make sense or no?
That does, thank you. And can we like put the interval with like brackets, or do we have to use like the alligator signs?
This would be fine, but not with brackets, because it's not moving to the left at 3 or at 9. It's stopped at 3 and stopped at 9. You can always write it out in words too. You can just say between t equals 3 and t equals 9, or from t equals 3 to t equals 9. And then that way you don't have to be as specific with the brackets or the parentheses or the less than or equal to signs. You can be a little more ambiguous about it, and they will give you the points for that anyway.
Okay, thank you.
No problem. All right. Part B. We're going to write but not evaluate an expression to give the total distance traveled. That should be easy. Part B, the total distance traveled. We know that total distance traveled is just the integral of speed, which is the absolute value of velocity. And I don't remember what interval they said. I think it was 0 to 6. Is that, if that's not right, tell me, but I think it was 0 to 6.
It was.
Oh, great. And that was worth 1 point. Part B, nice and easy part there. Part C was asking us to find the acceleration at t equals 4, which means we got to take the derivative of v of t. So using the chain rule to get the acceleration, the derivative of, now what was it? Cosine of pi over 6t, right? So that should become, taking the derivative of that, it should become negative pi over 6 on the outside because of the chain rule, sine pi over 6t. And we were looking at the value at 4. So a of 4 is negative pi over 6 times the sine of 2 pi over 3, which is 4 pi over 6. And we actually find that value, I think it said, right? No, it didn't. Yeah, okay. We didn't need to find it at 4. We just needed to find it at 4 to determine if the particle is increasing or decreasing speed. And since sine is positive and at 2 pi over 3, this is negative. This is less than 0. And since we know that's less than 0, we know the acceleration is negative. And then you'd look for v of 4. And v of 4 is the cosine of 2 pi over 3. And that's a second quadrant angle. And we also knew that's between 3 and 9, which we knew was when it was moving to the left. So it has a negative velocity. I'll say same sign, just like the last problem, speed increasing. And that was worth 3 points for this problem. 1 for the correct expression there, and 2 for increasing with a justification. Any questions there on part C? All right, part D. Find the position of the particle at t equals 4. So position at t equals 4 means we need to take our initial condition and integrate from 0 to 4 of cosine pi over 6 t dt. And our initial position was that at t equals 0, it was at negative 2. So negative 2 plus this. Everybody good with the setup there? One point for remembering the initial condition already. No points for the correct integral, but 1 point if you correctly anti-differentiated that. So integral of cosine is sine, but since it's got this pi over 6, it's a u sub, so you should be able to do that u sub. I'm not going to go through that process right now. 6 over pi sine pi over 6 t from 0 to 4. 1 point if you correctly anti-differentiated it. And then 1 more point if you correctly solved all the way down. And so that should be negative 2 plus 6 over pi times the sine of 2 pi over 3 minus the sine of 0. Sine of 0 is 0, so we can ignore that. Sine of 2 pi over 3 is root 3 over 2, so we've got negative 2 plus 6 over pi times root 3 over 2, or negative 2 plus 3 root 3 over pi. And that is your last point. Good or no? Any questions or issues there? Okay. Now we've got Ben on his unicycle. All right. Another non-calculator. Part A wants us to use the data to approximate his acceleration at t equals 5. And so that would just mean that we need to look for the average rate of change of the velocity. So that'll be at the interval that surrounds 5. So that'll be 0 to 10. So that'll be v of 10 minus v of 0 over 10 minus 0, or 0.3 over 10, or 0.03 meters per second squared as its acceleration. And that is just worth 1 point. And at the very end of the problem, it says if you had the correct units in either A or B, you get a point. So 1 point for the 0.03 and 1 point there for the meters per second squared. If you didn't have the right units in A, but you had the right units in B, then you'd get the points for it in B and still get that 1 point. Part B then says, using correct units, interpret the meaning of the integral from 0 to 60 of the absolute value of V. Well, we know that's the integral of speed, and the integral of speed is distance traveled. So that's the total distance in unicycles from t equals 0 to t equals 60. That's part A. Sorry, the first part of part B. So that's 1 point for that. And then the second point is they want you to approximate that integral using a left Riemann sum. And so we're integrating v of t. So we're going to use the v of t values. Our first height is 2 times a length of interval of 10. Our second height is 2.3. Length of that interval is 30. And the last one is 2.5 with a length of 20 from 40 to 60. And all you got to do is multiply all this out. That's 50, that's 20, that's 70, plus that is 69, 70 and 69 is 139, so 139 meters. So we're looking for a total distance traveled. So he unicycled 139 meters in those 60 seconds. That's some unicycling. Any questions there on part B? All right. Part C, we want to know for 40 to 60, is there a time when his velocity is 2 meters per second? So the first thing we might look at, there's a couple of different ways to go about this. Depending on, there's only one way to go about it for this particular chart, but there could be, depending on what the chart looks like, multiple ways. So first you could just look right here at his velocity. If his velocity was below 2, and then his velocity was later above 2, or vice versa, if it started out above 2 and went below 2, you would know that it must have crossed through 2 using the intermediate value theorem, because this is a continuous differentiable function, twice differentiable, meaning that b is continuous and differentiable and v is continuous and differentiable. So the intermediate value theorem would tell that if you started above 2 and finished below 2, or started below 2 and finished above 2, you must have hit 2 somewhere in there. But that's not the case, right? 2.5 to 4.6 doesn't indicate that you had to cross through 2. But we also know that the velocity could be 2 if, not the v of 2, but v equals 2 if the average change in position equals 2, right? Because that would be the mean value theorem. If you have a function that has an average rate of change on this interval of 2, then that must mean that the instantaneous rate of change on that interval must have also been 2 at some point. So we will look for b of 60 minus b of 40 over 60 minus 40. B of 60 is 49, I think, from the chart, and b of 40 was 9. That's 40 over 20, which is 2. And since the average velocity that he traveled on that interval was 2, we can be guaranteed that he was going exactly 2 meters per second sometime on that interval by the mean value theorem. Mean value theorem, v of t must equal 2, which is b prime of t. We would say on the interval 40 to 60. Does that make sense to everybody? Why it's the mean value theorem for derivatives there?
It makes sense.
All right. D. So we have a light directly above the western end of the track, and he rides so that at time t, his distance between the light and Ben is given by this equation. L of t squared equals 12 squared plus b of t squared. We want to know at what rate is the distance between Ben and the light changing at t equals 40. So write this equation. L squared equals, well, it's 12 squared, so 144 plus b squared, is that right? Yeah. All right, so we're going to take the derivative of both sides of this with respect to t. So this will be 2L dl dt equals 0 plus 2b db dt. And so this is just a related rate question here. The 2's on both sides can be canceled out, so we can ignore those. So we're looking for, what are we looking for? The distance between, or the rate at which the distance between him and the light is changing at t equals 40. So we're going to look for what is L at 40. And then we're looking for dl dt. And then we're looking for what is b at 40. And then what is db dt? Well, db dt, the derivative of b is v of t, isn't it? That's the velocity. So this ought to be v of 40. And we should be able to plug in b of 40 and v of 40, no problem. B of 40 is 9, and v of 40 is 2.5. And then L of 40 we'll have to figure out. So when L is, to figure out what L is at 40, it should be the square root of 144 plus b of 40. And like we just said, b of 40 was, sorry, b of 40 squared. B of 40 was 9, so this ought to be 144 plus 9 squared. That's 225. Square root of 225 is 15, so that ought to be a 15. We end up with 3/5 of 2.5, which 2.5 over 5 is half, right? So that's 3 halves. What were our units here? They must have been meters per second. Good or no? Any questions on that one? That was worth 3 points. 1 point for correctly taking this derivative, 1 point for recognizing that dB dt was v of t, and 1 point for the final answer. Everyone good? Any questions there? All right. How are we feeling about the motion problems?
They don't seem terrible.
That's good. All right, last one. We're not going to do any more after this one. So we're going to do this one, and then I'm going to let you guys go for today. I can answer questions you might have. But your last one. So this is the last one you should have already gone through. Again, we're given a velocity. This time we're also given an acceleration function. Plus we're given an initial position that at t equals 0, our position is 2. First thing we're asked is about speed. So we need to know if speed is increasing or decreasing. We know speed increases if the sign of velocity and acceleration is the same, and we know it decreases if they're opposite signs. So we're looking for v of 5.5, which thankfully we have a calculator to evaluate. V of 5.5 is negative 0.45 5337, if I can read this thing correctly, which is less than 0. Acceleration at 5.5, just plug 5.5 into this. And that one comes out to be negative 1.35851, which is less than 0. And since those have the same sign, we would say that the speed is increasing. And that is worth 2 points right there for noting that it's the same sign, therefore it must be increasing. Good or no? All right, part B. Find the average velocity. Well, we're given a velocity function. So if we know the function and we want to find the average of this continuous function, just do 1 over b minus a times the integral from a to b of that function. And since you have a calculator, your calculator will tell you that that is 1.949. And this was worth 2 points, 1 for the setup of the integral, 1 for the final answer. Good or no on part B? All right, part C, find the total distance traveled by the particle from 0 to 6. So total distance is an integral of speed. Speed is absolute value of velocity. So this is just an integral from 0 to 6 of the absolute value of velocity. And your calculator will tell you that that is 12.573. And that is worth, again, 2 points. 1 for the setup, 1 for the answer. Any questions or issues with any of that, A, B, or C? All right. Part D, which we would do here if, there we go, now my pen is working. Part D says for 0 to 6, the particle changes directions exactly once. Find the position of the particle at that time. So to figure out where it changes positions, we need to set v of t equal to 0 to see when it could potentially change positions. You only get one value when you graph v of t and look for its x-intercept. That is 5.19552. And we would note that it changes from, I believe it's from positive to negative. But if you're looking at the graph, you can just see that v is above the x-axis and then below the x-axis. So that's the one place, 1 point for that. And then they want to know what is the position of the particle at that time. So the position ought to be whatever initial position you know, which is 2, plus the integral from the time period in which you know that initial position, 0, to the value that you're looking for, the value of 5.19552 of just your velocity function. And that comes out to be 14.134. And 1 point up there, 1 point for the correct integral, 1 point for the correct answer, making sure that you included that initial condition. Any questions there on that one? Or anything else we've done today?